Hello, all. This is Mr. G, and welcome to Beating the State Test Round 4 Graphs and Tables. You know how these videos work by now. In this video, we're going to go over all of the released questions, the released items from the most recent state test that have to do with graphs and tables. So, what do we need to know before we attack these problems? Well, we need to be able to look at a graph and say, okay, when is it increasing? When is it decreasing? When did it hit its highest point? When did it hit its lowest point? We also need to be able to look at a table of numbers and sort of draw conclusions from that table. This is all pretty much easier to talk about when we're actually doing the problems, so let's not waste any more time. Let's jump right in. Number one, part A. A company owns some shares of M stock. The accountant for the company models the stock's price per share in dollars as its value changes over several weeks. A graph of the model is shown, and it's asking which statements are true about the value of the stock. And we have to select all that apply. Let's take a look at A. It says the value of the stock increases between weeks 4 and 8. Well, week 4 would be right here. So that's this part of the function. And week 8 is here. So it's that part of the function. Yeah, that's increasing. So far, so good. And decreases between weeks 8 and 11. Well, eight's right here, eleven's right there. And yeah, it's decreasing during that time period. So A is a correct choice. Let's select all that applies, so we have to check every single one of these. Let's take a look at B. The value of the stock decreases between weeks 0 and 2. All right, so week 0 is here. So the function's right there, or rather the stock value is right there at week 0. And week 2, it's right there. And that is decreasing. So far this is good. And decreases between weeks 2 and 6. Well, week 2 is right there. Week 6 is here. Well, no, that's increasing. That's increasing on average. I mean, it decreases slightly after week 2, but then it increases. So on average, that's increasing, which means B is not correct. Moving on to C. The value of the stock increases between weeks 8 and 11. 8 is right here, and 11 is right there. Oh, well, that's decreasing. So we don't even need to read any more of C. That's incorrect. Now we try D. The value of the stock decreases between weeks 0 and 2. So 0 and 2, from there to there, that's decreasing. Good. And increases between weeks 5 and 8. So 5 is right there, 8 is right here, and that is increasing. So D is a correct answer. Last up is choice E. It says the value of the stock decreases between weeks 6 and 9. 6 is right here, and 9 is right there. And that's an increase. That's an increase. So we don't even need to read any more of that. That's incorrect. So the answer is A and D. The only thing left to do now is check the answer. A and D. All right. Number one, part B. Which point shows the approximate lowest value of M stock? Well, if we look right here, the lowest value I see is right there. It never gets any lower than that point, and that point is point Q. So B is our answer, and I guess we check it. Yeah, B. That one wasn't too bad. Number one, part C. The company also owns shares in N stock. The accountant for the company models the stock's price per share for N stock. The graphs of the models for N stock and M stock are shown. After approximately what week is the value of N stock greater than the value of M stock? If we look at this graph, for most of it, M stock is higher than N stock until we get to this point right here. That's the point where N stock essentially overtakes M stock and becomes the higher value. So now let's take a look at which choice shows us that point. So week 1, definitely not. That'd be right here. Week 5, no. Week 7, no. Week 11, well, that looks like the best choice. That's sort of a weird one. I guess it's like 11 and a half, or maybe 11.7 or something like that when it actually overtakes it. So that's the best choice. We're going to go with D, week 11, and that's the answer they were looking for. All right. Number one, parts D. In which week did both stocks reach their lowest values? Well, we already did this for M stock. M stock's lowest value was right there. And if we look at N stock, it's actually kind of close. N stock, it looks like it hits its lowest value there and maybe there. So that could be kind of confusing, but the key word here is both. In which week did both stocks reach their lowest value? And the best answer is going to be right there, which is, what is that, week 3? That's choice B. Take a look. Come on. There we go. We got that correct. All right. Number 2. The graph shows the median percent cloud cover per month for 12 months for the city of Tampa, Florida. Because the cloud cover tends to be cyclical in nature, a sine function was used to model the relationship between median percent cloud cover and month. With the number 1 representing the month of January, the model C equals 55 plus 9 times sine of 0.98m plus 0.74 predicts the median percent cloud cover for month M. And we haven't even gotten to the question yet, but there's already a lot of really important information here. The first one is the graph. We really want to take note of that and pay attention to that as we go through the rest of this problem. The second clue we want to pay attention to is this model, this equation they're giving us to essentially predict, to model the median percent cloud cover. And we need to notice that the number 1 is for the month of January. Now that we've noticed the important clues, let's take a look at the question for number 2. Part A. It says which constant in the model gives the best representation of the average of the median percent cloud cover for the year. And let's remember when they're talking about the model, what they mean is this equation right there. That's the equation they're using to model the median percent cloud cover by month. What the people who made this question are banking on is that we are going to look at this equation, we're going to get intimidated by it, and we're going to get all scared, and we're not even going to read the problem, we're just going to skip it. But we're not going to fall for that trap because this problem is actually really easy once you understand what they're looking for. They're saying which constant gives the best representation for the average of the median percent cloud cover. So all we have to do is sort of look here and figure out, all right, about what number looks like it's the average of all these points. And it looks like maybe right there, somewhere there might be in the middle. So between 50 and 60, let's take a look at the choices. 0.74, no. 0.98, no. 9, no. Yeah, it's got to be 55. This is the only number in the choices that makes any sort of sense for the average of this graph. And yeah, we got it correct. So here we didn't even need this confusing equation. All we had to do was to be able to look at this graph and understand what it was telling us. Number 2, part B. It says the median percent cloud cover for the month of September was 58%. How does the model predict the amount of cloud cover for September? Well, we know the model they're talking about is this equation right here. So they're saying, how would this equation predict the amount of cloud cover for September? And then in the choices, it's giving us, all right, the model under predicts or over predicts the actual amount by less than 5, 5 to 10, or more than 10% cloud cover. Essentially, what we need to do in this problem is compare two things. We have to compare the actual median percent cloud cover of September, which was 58%, and compare that to, okay, what is this model, what is this equation predicting it's going to be for September? Now, this might look kind of intimidating if we had to do it by hand, but fortunately, this is a calculator question. So, a graphing calculator is going to make our lives a whole lot easier. Now that we've got our graphing calculator up and ready to go, we're going to type in this equation, but instead of M, we're going to plug in the number that would correspond to September. Well, remember, if January was 1, September will be 9. So we're just going to plug in 9 for M and see what we get. But before we do that, we have to make sure that we're in the correct mode. Whenever we're dealing with sine, cosine, or tangent, especially for an algebra problem like this, we're probably going to want it in radian mode. So I'm going to make sure I'm in radian mode. Now the difference is if we were dealing with like right triangles or we had an angle measure like 45 degrees or something like that, then we want to be in degree mode. But for this, radian mode is going to be the way to go. I'm going to hit second quit to get out of the mode menu, and then we're just going to type this in. So it's 55 plus 9 times sine of 0.98 times m, which is 9 for September, plus 0.74. Then we hit enter, and we get an answer of 53.79. We'll round it to the second place, the 100th place. Now we just have to compare that to what it actually was in September. So it looks like our model predicted 53, but it was 58. So that is an under prediction. The model under predicted it, and by how much? Well, I mean, we can probably do that in our head, but if you want to use a calculator, you just do 58 minus the 53.79. Just find the difference between them, and it's 4.21. It's less than 5. So those are the two answers we pick. Check it. We get under predicts and less than 5. Excellent. Number three, a lot of reading for this one. It says Gina rolled two number cubes, which essentially they just mean two dice, each numbered from 1 to 6, and calculated the sum of the two numbers landing face up. She repeated the process 100 times, and only once did she record a sum of 2. She suspected that the cubes might not be fair. So, what they mean by might not be fair is essentially the dice are weighted incorrectly or something like that, where the probability we're expecting for each number or each sum of numbers to come up isn't actually going to be the case. Essentially, Gina's suspecting that someone's cheating her with these dice they gave her. Let's keep reading. It says Gina reasoned that if the cubes were fair, the probability of rolling the sum of 2 is 1 over 36. Okay, so we don't even have to calculate that, they just gave it to us. For 100 rolls, 100 times 1 over 36 is approximately 2.8. So they're actually doing a lot of the calculating for us so far, which is a nice change of pace. She thought she should have seen the sum about 2 or 3 times in 100 rolls. Under the assumption that the cubes are fair, she conducted a simulation to determine what is a plausible number of times to observe the sum in 100 rolls. The results of 50 trials of the simulation are shown in the table. Let's take a look at the table. So here we've got the table they were talking about where the results of the simulations that Gina ran are shown. And it says, based on the results of the simulation, is there statistical evidence that Gina's number cubes are not fair? So essentially, Gina's trying to test this to figure out, okay, are these dice weighted improperly? Is someone trying to cheat me with these dice they gave me? Let's take a look at the choices. Now, I'm going to be completely honest here. Whenever I see a problem like this that's very statistics heavy, I get sort of, what's the word I'm looking for? Uneasy, because this is one topic of math that it is not my strong suit. So what I do whenever I'm in one of these situations where I've got a stat heavy problem to look at is I just sort of look at the choices and try and reason my way through it the best I can. But before I get ahead of myself and start looking at the choices, let's make sure we really understand what this table is telling us. Because if we don't understand the table, the choices aren't going to make any sense at all. So this table is the results of the simulation. And let's remember, Gina ran the simulation 50 times. That's why it says frequency out of 50. And then over here, it's talking about observations of the sum. So no times was 4. So that essentially means that 4 out of the 50 simulations, she didn't see the sum of 2 come up at all. In 5 of the simulations, the sum came up once. In 10 of the simulations, it came up twice, etc. So that's what this table is telling us. And let's remember what Gina was actually trying to figure out with this simulation. Originally, she rolled the dice 100 times, and only once she saw a sum of 2. Now, if we look at this simulation, and remember, this simulation was done under the assumption that, whatever dice were being used in this simulation were fair, we see, okay, one time happened 5 times, no times it actually happened 4 times. So I'm looking at this, and I'm like, all right, it seems fairly reasonable that she only saw the sum of 2 come up once, because, I mean, out of 50 times, 4 of the times, we didn't see the sum at all. So my initial guess is we probably don't have enough information here to say that the dice are unfair. But now that we've sort of talked about the table a whole lot, let's take a look at the choices. So A, it says yes, meaning yes, they think they are not fair. The greatest frequency in the simulation is 14. So this is the 14 they're talking about, okay. Indicating that the sum should have been observed 3 times. The number cubes are not fair. Okay, well, this choice doesn't make any sense at all because they're saying just because 3 happened the most in the simulation, that means she should have seen the sum 3 times. But I mean, if we look at the simulation, there's a whole bunch of simulations where it did not show up 3 times. So A doesn't make any sense at all. Choice B says yes, again, meaning yes, they're not fair. Observing the sum only 1 time out of 100 is equal to the probability 0.01. Such a small probability indicates that the number cubes are not fair. All right, this one doesn't look like a correct choice for a couple reasons. The first reason is that it's not even mentioning the table at all. Remember, the whole point of this table was to summarize the results of the simulation and help us figure out if there's enough data to prove that these number cubes are not fair. So the fact that this choice B doesn't even mention the table has me suspicious. The second reason I'm skeptical of choice B is because like this sentence right here really doesn't make sense. So it's talking about, okay, only 1 time out of 100 is equal to zero point zero 0.01, so that's 1%. Such a small probability indicates the number cubes are not fair. That's not true at all. Just because something has a very low probability of happening doesn't mean that there's something unfair going on. Plenty of things are unlikely to happen, but that doesn't mean we're being cheated somehow. So I don't think B is the correct answer. Let's take a look at C. It says no. Observing the sum once or never occurred in 18% of the trials, indicating that the observation is plausible. There is no evidence that the number cubes are not fair. All right, this sounds promising. Let's take a closer look though. So the sum once or never occurred. So we're talking about no times or one time. And this 18%, oh, okay. So if we add those together, we get 9, and 9 out of 50, that would be 18%. Because if we double 50 to get to a denominator of 100, we double 9 and we get to 18. But again, they're doing that calculation for us. So even if we weren't sure exactly how to figure that out, they gave us the number. And it says indicating that the observation is plausible. And I really like that phrase because in 4 of the trials, if we didn't see the sum at all, and in 5 of the trials, we saw it happen only once, then yeah, it seems reasonable that if we rolled the dice 100 times, we might only see that sum of 2 come up once. Maybe it's not really likely to happen, but it's certainly possible. So choice C sounds pretty good, but let's take a look at D just to be sure. D says no, the sum was observed from a minimum of no times to a maximum of 7 times in the simulation. Observing the sum one time falls within the interval of 1 to 7. The number cubes are fair. I do not like this choice as much as C, and let me see if I can try and explain why. One thing I don't like about it is this sentence right here where it says observing the sum one time falls within the interval of 1 to 7. It's like, okay, technically that's true, but I don't know if that's a real solid mathematical argument. Like this whole 18% argument sounds a lot better to me. And the other thing, and this is really, in my mind, the nail in the coffin for this choice, it says the number cubes are fair. And when I see a definite statement like that, especially when I'm doing like a stat or a probability question, and it says, oh, they are definitely fair, that makes me wary. I much prefer the, oh, there is no evidence that the number cubes are not fair. So essentially, that's saying they might not be fair, but based on the table they're giving us, we cannot definitively say that the cubes are not fair. So I'm going to go with C as the answer. And let's check it. And there we go. That's it. And that's the end of the video. As always, I hope this was helpful. If you have questions, by all means, let me know. Enjoy the rest of your day.